Hey everybody, this is Paul. Welcome back as we continue to create a binary search tree project in C++. In this tutorial, I'm going to be creating a helper function that we will be using in our remove node functions. If we want to remove a node that has two children, then we're going to need to be able to find the smallest node in that node's right subtree. So we're going to be creating a helper function to help us do exactly that in this tutorial. Here in the public section of my binary search tree.h file, I'm going to create a function prototype that has an integer return type, and I'm going to name this find smallest. And I'm just going to do an opening and closing parentheses here and end it with a semicolon. Let me just go ahead and copy this right here, and then I'll paste it up above. And if you've been following along, you probably know exactly what I'm about to do here. I'm going to create a private version of this that we can use to recursively move through the tree. And our private version is going to need to take in a node pointer, and we'll just go ahead and name that PTR. So let's just go ahead and copy this one right here. We'll paste it into our binary search tree.cpp file, and then we'll just go ahead and type in bst : so our program knows we're defining this from the binary search tree class. Now let's just go ahead and copy this one, and then we'll just go ahead and paste it down here. We'll just get rid of the private there, get rid of both of these semicolons, and then we'll put an opening and closing curly brace for each of these functions here. Let's just go ahead and cut that one, and we'll put that one up top. It doesn't really matter to do that, but just to be consistent with what I've already been coding, we'll just go ahead and do it this way. And then the find smallest function doesn't need a node pointer, so we'll get rid of that. So now we're all set up to go ahead and define these functions. So the find smallest function is going to be the one that we will call from our main program. And all that's going to do is it's going to call the private function, which is going to be the recursive function. And we're just going to make sure that it starts the recursion at the root. So we'll go ahead and say find smallest private, and we'll start at the root. So in the main program, all we can really do with this is we can just find the smallest in the tree. In our other functions, we can use the find smallest private, and we can start at a subtree if we would like. So that way when we go to delete a node and we need to find the smallest key value in the right subtree for deleting a node of two children, we have a way to pass a pointer in so that we can begin at the right subtree. So for the find smallest private function, we're first going to check to see if the tree is empty. So we'll say if root is equal to null, that means our tree is empty. Then we'll just go ahead and print a message to the screen that lets us know the tree is empty. And then because this has a return type of integer, we're just going to cheat a little bit here, and we're just going to give it a return value of -1000 because we don't have any negative numbers in the tree. So that way it's happy, it gets an integer return value, but it's not going to be any value that we have in our current implementation. If you end up having negative numbers in your binary search tree later on, you'll need a different way to go about this, but for our implementation, this will work just fine. So if the root is not equal to null, then what we're going to do is we're going to take care of that in this else portion of the function here. So the first thing we're going to do in this else section here is we're just going to check to see if our left pointer is pointing to a node. So we'll take care of that by saying if ptr arrow left is not equal to null. So if our left pointer is not pointing to null, that means it's pointing to a node. And so we want to go ahead and traverse down that left pointer. So to do that, we're just going to say return, and then we're going to recursively call the find smallest private function. And this time we're going to pass in the left pointer. And we don't really need to look down the right side because any node we're pointing to, if it has a right child, the key inside of that right child is going to be greater than the parent. And so we don't need to look at the right child because that will always be bigger than the node we're currently looking at. If our left pointer is pointing to something, we're going to recursively keep checking. Otherwise, we're going to go ahead and return the key inside the pointer we're looking at because that means we found the smallest key in the subtree. We've gone as far left as we can, and in the else statement here, our left pointer would be pointing to null down here. So that means that we've made it to the smallest node in the subtree. So in that case, we're just going to say return pointer arrow key. And so that takes care of the find smallest function. So let's just go ahead and make sure we have all these files saved, and we'll just go ahead and test this really quick. Open up the terminal here, and I went ahead and checked through all of these values in the last tutorial just to make sure that the structure of our tree was correct. And so all of these values are correct from the last tutorial. So let's just go ahead and use the clear command to clear the screen. And I guess I need to go ahead and put something in my main.cpp file here really quick. For this tutorial, we don't really care about this chunk of code right now, so we'll just go ahead and delete that. And then we're going to have our tree go ahead and call the find smallest function that we just created. And the smallest number that we placed in our tree was the number 2. So if everything works correctly, then we're going to have it print the value 2 to the screen. So we'll just go ahead and put a cout statement here, and we'll say the smallest value in the tree is, and then we'll just go ahead and end the quote there, and then we'll just grab that smallest value. And I guess we should probably do a new line as well. And so let's just go ahead and save this now. Go back to our terminal, compile our program, g++ main.cpp, and it says we have a problem on line 159 of our binary search tree.cpp file. And let's see, we've got right there. I just forgot to put the return keyword here since we are returning a value here. So that should take care of that. I'll save this file. We'll go back to our terminal. We'll try to compile this one more time. Looks like that worked this time. So now we do ./a.out to run the program. And sure enough, it says the smallest value in the tree is 2, just like we expected. So in the next tutorial, we'll go ahead and keep working on this project. So anyway, thanks for watching. Have an excellent day, and if you haven't already, don't forget to subscribe.